Hey kids! Have you ever wondered why Robert can flex his arm like this, even though while he's lifting this very heavy water bottle? So if you were ever so curious, here's Muhammad to tell us more.
Muscle contraction starts in the motor neuron. It sends an action potential, and that action potential travels through the axon and hits the axon terminal. And that causes the calcium channels to open.
Oh boy, that was surely interesting. But wait, there's more!
When we enlarge this part, we can see that the axon terminal is not actually connected to the muscle cell. There is a gap between them, and it is called synaptic cleft. When the signal reaches axon terminal, the calcium channels open and the calcium ions enter the axon terminal through the channels. It causes some synaptic vesicles to release acetylcholine, diffuses across the synaptic cleft and binds to the receptor in the sarcolemma. When acetylcholine binds to the receptor, the ion channels open and allow sodium ions pass through the channels and let potassium ions to leave.
Wow, that was very interesting and not confusing at all. But wait, there's more! Man, I really sound like a person from an infomercial. If you could just hurry up. Thank you. Now, after the release of this neurotransmitter, this in turn sets off another action potential inside the muscle cell. This travels along the membrane of the muscle before entering it through folds that are called T-tubules. And yes, I understand I cut off T-tubules. Give me a second. See, there, T-tubules. Got it? Cool. Outstanding. I know what you're thinking. That's it, right? Nah, there's a crap ton more. This is only the beginning. I'm now going to take you inside the sarcomere, which is filled with two filaments, actin and myosin. Now, what we have to remember now is that myosin and actin can't stay away from each other. They're like basically a twerk circle at your local Berea Mid-Park High School homecoming, winter formal, if anybody even still goes to winter formal, and of course, to all you seniors out there, prom. Yeah. What we also have to remember is that each muscle cell is covered with a lining called the sarcoplasmic reticulum. The SR's main purpose is to basically burn up ATP molecules to create a surplus of calcium. So for now, let's think of the red dots with circles and stuff as ATP molecules and the green things with red lining on them as calcium ions. What we also have to remember is that actin is always being guarded by troponin and tropomyosin, which is basically the chaperones at the school, that try to keep a twerk circle from happening, but for some reason are never successful in any way, shape, or form. And it's kind of funny to laugh at them when they try so hard, but yet everybody still keeps twerking. Okay, so all awkward, cheesy, unnecessary, really weird, and, uncomfortable twerking jokes set aside, remember those action potentials I was talking about? The ones that are released through the motor neuron down the axon into the axon terminal, which then in turn sets off a neurotransmitter, which then also in turn sets off another action potential that travels down the sarcomere, which then enters the muscle cell through folds called T-tubules. You guys remember that? It's okay. I don't either. Well, I do, but whatever. So basically that action potential that has traveled down into the muscle cell sends a signal to the SR, sarcoplasmic reticulum, to open and let all those calcium ions that it has accumulated from breaking ATP molecules in. Calcium will then bind with the troponin, which causes the troponin to rotate around the actin, moving the tropomyosin out of the way, allowing the myosin to, go to town. Basically, how myosin does reach up and grab the actin molecules is very simple. Each myosin holds one ATP molecule, which is in short for adenosine triphosphate. It breaks its phosphate and the force of it breaking off that phosphate allows it to have enough energy to reach up and grab that actin. Basically, what you're going to see here in a minute is that after it's all done grabbing the actin, the force of that in turn will actually pull the muscles in towards the middle of the sarcomere, causing your muscle to contract. Yep, it's that easy. So yeah, that's muscle contraction. So bye.